Two of the biggest buzzwords in 3D printing for 2025 are tool changers. The idea of printers with multiple swappable heads is nothing new. But most existing solutions either required a massive investment of time or were locked behind a price that's hard to justify unless you're running a serious business. So when Snapmaker announced the U1, a 4-headed tool changer at a fraction of the cost of anything else on the market, heads turned. Today's video is brought to you by Squarespace. And while I still had a healthy level of skepticism, my positive previous experience with their IDEX printer, as well as some of the early demos I saw, were enough for me to jump in and become backer number 39 on Kickstarter. The printer I backed actually showed up during the editing process of this video. But Snapmaker also reached out and offered to send me one of the first retail units off the line for testing. That's given me a little under 2 months to see what this printer's all about and if it delivers on its claims. In today's video, we'll dive into the U1, go over its specs, walk through the setup process, look at some prints, and I'll share my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. For anyone that didn't see it, I released a video right around the time the U1 went live on Kickstarter, talking about why I decided to back it, as well as why I held off on receiving the early production unit Snapmaker had offered me for testing. I had been told by Snapmaker they were going to get back to me about receiving a production unit, but after 3 months, I started to believe this wasn't likely going to happen. So I was pleasantly surprised when I got an email in September letting me know that they had one and it was ready to ship. Before we get into the specs of the U1, I just want to quickly touch on some of the reasons or benefits of a tool changer machine for anyone that might not be familiar. As of right now, there are really 3 primary reasons I think that someone would want a tool changer over something like a single-headed printer or a printer that's got a filament swapping setup like most of the rest of the printers in here. And those are printing speeds, minimizing of waste, and the ability to combine dissimilar materials. Speed mainly comes from skipping the unloading and loading sequence of filament every time you change color or material, as well as removing the time that it takes to purge the existing material in the hot end. The waste comes from that purging sequence. If you've seen any video almost on a printer that is multicolor, you've likely seen the piles of purge material or filament poop coming from those machines. And when it comes to combining dissimilar materials, having a dedicated tool head or hot end for a specific material is much safer than trying to swap between a flexible and rigid material multiple times in a print or a lower temp and a higher temp. That is a great way to get a really nasty clog. This video is sponsored by Squarespace, the all-in-one platform designed to help you stand out and succeed online. I built my ModBot Army site on Squarespace to finally have a hub for everything I do. New videos, sponsor info, and a way for viewers to get in touch. Their Blueprint AI makes getting started a breeze by asking simple questions about your goals and automatically building a layout around them. You can then use their award-winning templates and drag and drop editor to customize everything. Squarespace also gives you the tools to help people actually find your site. Every website is automatically optimized with built-in SEO features like meta descriptions and an auto-generated sitemap so you can show up more often in search results. So if you've been thinking about launching a site, head to squarespace.com/modbot to start your free trial today. And when you're ready to go live, use code MODBOT for 10% off your first purchase of website or a domain. The Snapmaker U1 is a Core XY tool-changing 3D printer with a build volume of 270 millimeters in X, Y, and Z. It ships with 4 tool heads, which is also the maximum number it supports. For motion, the Y-axis uses steel rods and bearings, and the X-axis uses carbon fiber rods. This is really similar to what is on the X1 Carbon, and while I haven't had any issues with them, I have heard from multiple other users that the carbon fiber rods over time ended up being problematic. In an attempt to avoid any potential issues, there is a maintenance schedule, and it is recommended to clean those carbon rods once a month with isopropyl alcohol and a clean rag. The printer's bed is driven up and down using 3 lead screws and 3 smooth rods. This is a pretty standard configuration for a lot of Core XY printers now, but those 3 lead screws are driven by a single motor, and on the underside of the printer you'll find a belt that is wrapped around all 3 lead screws with the motor, as well as the belt tensioning mechanism. As for the build, the frame itself is made of steel with a handful of injection molded pieces connecting everything together. The inside and outside of the printer are largely covered in big plastic panels, which gives it a clean aesthetic, but they are a bit more flimsy than I would like, especially around the top, and even on the side, if you press in on them, there's quite a bit of flex. The main concern I'd have is when you are moving this printer, make sure you are grabbing it from the base or somewhere that is solid. The front door of the U1 is made of glass, and there's also a pretty large clear window on the back made of acrylic. I'm not entirely sure what their thought process was and why they made the back see-through, but it does make for a fun time when recording. Since this is a tool changer, the tool head is comprised of 2 main pieces. You have the portion that stays attached to the carriage that does the grabbing, and the 4 tools that get picked up and parked at the docks on the back of the machine. The grabbing portion consists of a layer cooling fan at the front and 2 pins along with a kinematic coupling on the back that are used to attach to each tool head. Each of the tool heads has its own built-in direct drive extruder, cooling fan, all-metal hot end, and filament runout sensor. There are no wires connecting the carriage to the tool head, and instead it uses a series of 3 pogo pins. These are technically a consumable, and Snapmaker states that they are rated at up to 250,000 swaps per tool head. I haven't had to swap out any of mine yet, but there are pre-orders available for the replacement PCBs on Snapmaker's website, and it's something I recommend everybody purchasing one of these pick up a set of to have on hand. The U1 uses automatic bed leveling with what I believe is a load cell. I didn't see anything under the bed, and in the tool head that I took apart, I also didn't see anything standing out looking like one, which leads me to believe that it's probably in the main carriage itself. For being a tool changer, the wiring on this is really clean, and the only thing going from the printer itself to each tool head is a single USB-C cable as well as a filament guide tube. For docking, the tool heads are slid onto a long rod and then moved to the side where they are held in place using magnets. As for each of the tool heads themselves, they are largely made up of a machined aluminum block that a lot of the hardware attaches to, and there's a few smaller injection molded pieces as well. The back cover of these is only held on with magnets, so if you pull it off, you can get a quick view of the overall toolhead's layout. The printer ships with 0.4 stainless steel hot ends in all of the toolheads, but on Snapmaker's website they have 0.2, 0.4, 0.6, and 0.8 hardened steel hot end variants available. I already ordered a set of 4.4 hardened steel hot ends because I'd like to have a bit more options and variety of materials I can test on this printer. Underneath each of the parking locations is a pad to keep the filament from oozing, a brush for running nozzle scrubbing, and a PTFE wiping latch that's used to remove any purged filament when loading a spool or running the extrusion flow calibration before a print starts. Because of this, there is a filament purge or poop catcher built into the inside back of the machine. This fills up really slowly since it's only occasionally doing a tiny bit of purging, but you'll want to at least keep your eye on it and dump it before it fills up all the way and potentially causes an issue. The bed uses a magnetic flex plate system, and it ships with a dual powder-coated PEI sheet. Instead of using a magnetic sheet, it uses fairly large rectangular magnets that are embedded into the base of the bed, which does a really great job of holding down the bed firmly. There's also 2 alignment pins located at the back of the bed, which is really convenient when you are reinstalling your build surface. Other things worth pointing out inside of the printer are two LEDs on the right side for lighting up the work area, a camera at the front right corner of the printer, and an auxiliary fan on the left side to help out with your layer cooling. While I hardly use the camera during my testing, the biggest complaint I have is that the frame rate is very slow. It's fine to quickly check in and see whether you've got a shifted part or some sort of a spaghetti mess, but outside of that, it is not very enjoyable monitoring prints using that camera. Interfacing with the printer is done using a 3.2-inch touchscreen on the front right side of the machine. Overall, my experience with it has been quite positive. It's bright, it has a large viewing angle, and it's been responsive. The only thing I can really see someone complaining about is that because it doesn't have a tilt functionality, it could be a little bit of an issue depending on the height that you have the printer set at, especially if you're using something like tall racks. On both sides of the printer, there are two spool holders as well as a filament loader. The spool holders look like they are near identical as to what comes on the AMS Lite, which I've been a big fan of, and it allows them to work with a wide range of filaments with different inner spool diameters. Each of these slots also have RFID readers built into them, so if you happen to be using Snapmaker Filament, the second you pop it on there, it can detect the color and the material type. The autoloaders are also a really nice function. Instead of having to manually push the filament all the way into the toolhead, you just insert it into the filament loader, it senses filaments there, and it will load it the rest of the way for you. Due to the internal design of the mechanism that loads both of these spools, it isn't able to unload, so you do have to manually pull it out, but I greatly preferred the unloading just by pulling the spool versus having to manually feed filament in. The only issue I ran into a couple times with these loaders is that if you're like me and when you're storing filament, you kind of shove the excess through the little hole or cutout in the side of the spool, sometimes that can create a bit of a kink in the filament, and these loaders do not like that kink. It will cause it to basically catch, and you'll have to correct it before it can load your spool. So my recommendation is either to make sure you straighten that bend or that kink out, or what I've been doing in a lot of cases is just cutting the filament right where that bend is, so that way it can load without any problems. At the back beside the window, you'll find your power input and on-off rocker switch, along with a full-size USB port and a port labeled as add-on. I believe you can use that USB port for printing without a network connection, but due to its location, unless you have it set up like me right now in the middle of a room or have a USB extension cable you plug into it, clearly the main plan was to have users print over Wi-Fi. There isn't an option for Ethernet built into the printer, but someone in my live stream told me that you could use a USB to Ethernet adapter, and based off a forum post I found while working on this script, that does seem to be the case, but it is not something I've tested out. The U1 is completely open on top, but Snapmaker does sell a top hat or enclosure kit for this printer. I can't remember the exact price during the Kickstarter launch, but it looks like based on their website, the retail price of that enclosure is $250, with it being on sale for Black Friday or for the holidays right now at $150. I primarily plan on using this printer with PLA, PTG, and some TPU, so I didn't opt to purchase the top enclosure, but I am hoping that a community mod ends up coming out that incorporates more printed parts with maybe some smaller acrylic panels that will bring that cost down, because it would be nice to just keep dust out of it, as well as be able to experiment with things like ABS, ASA, or other higher temp materials. I haven't seen any install instructions for the top hat or that top enclosure, but it does state that it has a HEPA filter, and so I am imagining that this plug that is here between the four tool heads is likely to power and control that filter. The entire unboxing, setup, and installation for the U1 was done over on Livestream on the Modbot Army channel, so for anyone that is interested in watching that, I will have that linked in the description. From unboxing to the first boot, it took us an hour and a half, but that was with a lot of shenanigans, and the process of getting everything out of the inside, removing all the shipping screws, attaching the loaders, attaching the feeders, and getting the cables all screwed in correctly, for most, I would say, is probably around an hour. We went through the on-screen calibration and setup process as well on stream, but since there have been at least one, if not a couple, firmware updates in the time I've had it, I did a hard reset of the printer so I could see what the process was like and if it had changed at all. On first boot, it has you select your language, optionally connect it to Wi-Fi, and pair it with the Snapmaker app. Then it does the toolhead offset calibration. This only needs to be done once unless you run into some sort of a weird error or you have swapped out your hot end. And basically it's going to take all of your toolheads and measure the offset of X, Y, and Z between them. This is largely an automated process and is done by removing the powder-coated PEI to expose this large sort of hole or pad in the bed. From here, each toolhead is grabbed, warmed up, cleaned, then brought to the front where it tells you to use the included wire brush to clean it, then it goes and takes its measurements. I did mention that this does have a built-in scrubbing brush, which it does automatically. That is still the case with this. The reason I believe they want you to check it and use the wire brush that's included is just for some sort of redundancy, and perhaps there's a situation where the nozzle is just coated in filament and the built-in scrubber can't clear it. Well, these nozzles for this needs to be clean because this ultimately is going to determine how aligned your tools are when printing, and so it is a very important step. All in all, this process takes around 15 minutes, and from my testing, the results have been incredibly accurate. Once this completes, the printer performs a massive 169-point bed mesh. This is something that I thought they were going to be reducing with the firmware update, but it doesn't seem to be the case. However, the thing I did notice is it feels like the toolhead is moving through each location much quicker, and I think that the entire mesh was only somewhere between maybe 5 to 10 minutes, which feels a lot faster than the time it took when we were on stream. Then the final portion of the calibration process is running input shaping. From here, you're ready to load in your spools of filament, which starts by just popping them on these side loaders, pushing them into the feeders, and having them grab them and feed them up to just right above where the tool heads are. From the filament menu on the screen, you can tell it the type of filament loaded into each slot as well as the color. I really like the way they set up the filament loading and unloading menu. You basically tell it whether you want to perform loading or unloading, then you select a checkbox next to the tool heads you want to load and unload, so you can do one, a couple, or all of them at once. And with a tool changer, because you're going to be unloading and loading filament quite frequently and there's just a lot of moving around, having that might be a small detail, but it really makes the workflow a lot less cumbersome. The last thing we did on stream after loading in the 4 spools of included Snapmaker PLA was start printing out the included test file of a 4-colored dragon. This turned out awesome, and I think it did a really good job of, one, showing you the toolheads in action, but also the machine's capabilities, even on something that's at a smaller scale. Before covering my printing experience and showing you some of the things I printed, I want to quickly touch on the firmware and the slicer. For the firmware, the printer is running Clipper, and that's awesome. My favorite part about this is that nothing is hidden, and if you grab your printer's IP address and enter it into your browser, you are greeted by the Fluid dashboard. From here, you can see the crazy amount of macros that they have set up to make this tool changer work, and you can even access your printer.cfg file. For many, that might not mean much, but for those proficient with Clipper, it does mean you can go in and make changes to things and have the freedom to customize things if you feel the need to do so. The next question, I'm sure, is there SSH access? And from my brief searching, it doesn't appear to be that way at this time, but I hope that is also something coming for those that want it. As for the slicer, the Snapmaker U1 uses Snapmaker Orca, which is a fork of Orca Slicer. This is what I used for all of my testing, and as far as I can tell, the primary differences are on the device page as well as the page that you see when you go to print or upload a file to the printer. At the time of recording, the Snapmaker U1 is in mainline Orca Slicer, so you're more than welcome to use it, but the device page is the Fluid dashboard instead of the Snapmaker kind of simpler UI, and I prefer the method of assigning colors or materials to tools built into Snapmaker Orca over what's currently in Orca Slicer for this printer. So I'm hoping that's something that can maybe be patched or added in to Orca Slicer for the U1. However, Snapmaker Orca worked totally fine for me, and if you're used to using Orca Slicer, you'll feel right at home in that slicer as well. So how does it print, and have I ran into any issues so far? For a large amount of my printing, I've been doing multicolor PLA prints, and that's primarily because it's a big part of what I plan on doing with this printer, and I also have a feeling that if I took the larger majority of people that back this printer, that is also likely what they have planned for their U1s. And for this, I have been very pleased. The speed gain of not having to load and unload filament each time there's a swap is something I knew of and expected, but it still surprised me with how many prints I thought would take a day or even days that ended up only taking a fraction of that. For my testing, I stuck with the stock profiles. This is typically what I do because I want to see what the user can expect without doing any sort of custom profile tuning. And the main area I saw room for improvement in came in the form of light stringing. I did end up slightly lowering some of the print temps, which helped a little, but I'll likely go in further in the future and do some retraction tests to see if I can hone this in even further. Color placement between the tool heads has been spot on, which shows me that the nozzle or tool head offset calibration it does at the beginning is effective. And from the time I have assembled this and turned it on until now, I have not ran into a single issue with docking or attaching a tool head. And that's even after moving the printer twice. I did notice some inconsistencies with layer stacking in a couple of prints that I need to investigate further, but at this time I still largely believe that it is something that can be fixed with a slicer setting. Another thing I am sure is going to be very popular with a tool changer or printer like this is using PLA supports on a PETG print or PETG supports on a PLA print, since they do not stick together, and you can set your gap or your layer interference layer to a gap of 0. I briefly tested this, and as expected it worked well, but it was also a good reminder to dry your PETG. The only real issue I ran into during my printing was when I tried to run a print that combined PLA and TPU. The first failure was a simple fix, and it came on because the printer, or the way it sliced it, chose the bed temperature for TPU, which was 35 Celsius, so the PLA ended up warping. And to resolve that, I just set the TPU and PLA profiles to be at the same bed temp. Once I corrected this, I fired off the print again, and the second print led to a pretty nasty clog that required me fully disassembling that tool head. I have to give credit to Snapmaker because they do have a step-by-step video of the disassembly process, but man, getting inside of that tool head to get to that extruder clog was a royal pain. You basically have to remove just about every single thing from the tool head to gain access to be able to remove the extruder, and I can absolutely see somebody damaging a cable or putting something incorrectly back together during the reassembly process. I cleared the clog, got everything put back together successfully, and reran the print, but in the back of my mind, I was dreading having to go through that process again. I understand them wanting to keep things compact and having definite design challenges when building a tool head, but I just really wish that the extruder was more accessible, because it is the primary point where if there is a clog, you're going to need to access. The good news is that the print completed successfully, and this is the first time I've combined two dissimilar materials like this into a finished print. And while this is a somewhat simple model, it is still very cool, and I can only imagine with more tool changers being out there giving designers the freedom to create more things that they couldn't create before, we're going to see more and more use cases and models that are taking advantage of different materials in the same print. For anyone wondering about noise levels, I did use my phone from about a foot away from the printer with the front door open, printing PLA, which is basically loudest case scenario, and it was between 60 to 62 decibels with an occasional spike up to 70 decibels when there was a quick movement from the printer. I imagine that with that front door closed and the top enclosure on for anyone that's getting that, it will be a fair bit quieter, but as is, it is a pretty noisy printer, but thankfully completely silent when idle. So what are my thoughts on the U1 based on my time with it so far? Well, largely positive. From setup to calibration and printing, it's been a positive experience. Printing with this machine feels similar to printing with any other machine that I regularly use, except now it's faster, has less waste material, and gives me more options. There's nothing about this machine being a tool changer that makes it feel intimidating, which I believe is exactly what Snapmaker's goal was when they were designing the U1. Most of my complaints are relatively minor in the grand scheme of things and don't affect the machine's performance. I think my only real standing concerns are how accessible are spare parts going to be considering the large volume of printers they need to produce for the Kickstarter, as well as people that will be still actively buying them. Two, how will this printer hold up over time? Yes, it's really just a 3D printer with 4 different tool heads, but still with the docking and undocking, there's different components in here that you wouldn't find in a normal printer. So I'm curious to see over time how those do. And then finally, while I got a first-hand experience of what it's like to get inside the tool head, it is something that can be done even if it's not enjoyable. And I'm curious to see when and if other issues arise on the machine, just how user serviceable they truly are. I really like that I am at least seeing lots of spare parts being populated over on the web store. And it seems like over the past couple of weeks, Snapmaker on their YouTube channel has been rolling out different teardown or repair videos that is going to be really helpful for support and their end users. And I hope that what we're seeing is just the start of a much longer initiative. For a lot of people, this will likely be their first entry point into tool changing. And from what I'm seeing here, I think that most are going to be pretty pleased with the experience. Snapmaker seems to have cut corners in all the right places, allowing them to offer a tool changer to the masses at an incredibly competitive price point. And I hope to see continued development in this space. After my 2 months with this machine, I can gladly say that I would back this printer again. And that's been the Snapmaker U1. I hope that you enjoyed this video and that you have a better understanding of what it is, what the setup process is like, and what you can expect from it. If you have any questions, let me know in the comments down below and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to Snapmaker to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every single week, so there's always fresh content coming your way. And if you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!